In the previous video, we were able to get to the least squares line, and we were able to verify an interpolation using this equation for the above data. And we're going to take things one step further in this video, and we're going to start taking a look at the residuals. So the first thing we're going to do is we're going to plot the residual, or we're going to compute the residuals. And remember, our formula is that we're going to take each of the x or the explanatory variables, and we're going to plug that into the least squares equation. And remember, we called that y predicted, and we're just going to call those y1, y2, y3, and y4. And for the first one, 5.362, and we're going to plug in the first x value, which is 77, in for x, minus 175.56. And then we're going to do the same thing, except we're just going to go right down the line. And we have 75 or 76. And then we have 75. All right, now, remember the trick that we use in our calculator? We just type in the first one, and then we can hit second enter and just type in the other three. So we can just go ahead and type in 5.362, parentheses, 70, I think it was 77 for the first one, just make sure. 77, and then 175.56. So 77 minus 175.56. All right, so there's our first one. And then we're just going to hit second enter. And we're going to type in the second x value, which was 71. Oop. And we're going to type in the third, which was 76. And finally, we'll type in the fourth one. And hopefully the first three don't go away because we have to copy those down. 75 and enter. All right, and I'm just going to pull this to my other screen really quickly and bring this back up. All right, so the numbers that I got, 237.314, and then 205.142, and then 231.952, and then finally 226.59. All right, now we can compute the residuals. And the residuals are going to be the actual minus the predicted. Okay, so y actual minus y predicted. So, and we call these E1, E2, E3, and surprisingly E4. All right. Now the actual data, remember, you get right from here. All right, those are the y values, and you were right from the original data. So that's going to be 244, and then 206, and then 225, 214. And then we're going to subtract out the predicted values, 237.314, and then 205.142, and then 231.952, and then finally 226.59. All right, so let's get our residuals. All right, and this is the most painful part. After we're done with this, the rest of it's mostly analysis in the small graph. So back over here, we have 244 minus 237.314. Right? And then we have 206 minus 205.142. And that's a small one. Then we're going to have 225, which is the third y actual, minus 231.952. And then finally, the last one, we have 214 minus our 226.59. That might be the largest one. All right, so here's all of our numbers for the residuals. And let's go ahead and substitute those back in for our actual data. Okay, so our residuals are going to be 6.686 and then 0.858 and then negative 6.952 and then finally negative 12.59. All right, so if we're looking for which, and those are the residuals, so that's actually going to be part F, I believe, if we go back up here. Now we just want to identify the point closest and the point furthest. So the point closest to the line is the smallest absolute value. And this is clearly going to be the smallest number that we have if we take the absolute value. Okay, so for part G, the point closest is 0.2. And that's because we just look right here and it says E2. All right, so our second error is the smallest. And that point, if we go all the way back up, the second ordered pair is 71,206. Okay, and the point furthest is going to be the absolute value of the largest number, which is going to be 0.4. All right, so if we look over here, negative 12, absolute value is positive 12, and 12 is certainly larger than 6, 6, or 1. And so E4, or 0.4, is going to be the point that's furthest from the line, and that is going to be the point 75, 214. All right, and again, just to make sure everybody knows where I got that from, all the way back up here with the data. So this is E4 or 0.4, and this is 0.2. All right, so that's the easiest way that I think you can identify the points that are closest and furthest. All right, now we need a residual plot. Right, so I'm going to do that down here, and this is item H. Now for our residual plot, okay, so we have 0 right in the middle, okay, and we're just going to have the points. So we're going to or the residuals. So we have E1, E2, E3, and E4. And this is 0. And let's call this 6. Let's call this negative 6. And let's call this 12. And let's call this negative 12. And we're just going to go back up. And you recall the residuals are right here. So positive 6.686. And then negative 6.952, etc. And all we're going to do is we're just going to plug those directly in. Okay, so let's go back over here. And so E1 was about 6.686, so that's going to be right about here. And the other one, or E2, was 0.858, so that's really close to the line. And that makes sense because E2 was the closest, remember? And then E4 was the furthest. So let's just see by our residual plot if it's significantly further. Negative 6.9 was right about here. And then finally, we had the point negative 12.59. All right, so that's pretty far away. All right, that's about right there. Okay, so what we're looking at is the residual plot. And our residual plot, if we go all the way back up, based on the residual plot, do you feel if there's any outliers? If so, identify the pair. And it looks like that this point is significantly further away than the rest. So we could say something to the effect that the point, and remember it was the fourth point, which was 75, 214, seems to be furthest away from 0 and may be an outlier. All right, now later in the course, we're going to define what is an outlier and what's not numerically. So far, all we've done is we've just kind of eyeballed what these sort of outliers are. So hopefully this gives you a good overview as to how to go through, construct the residual plots, and then also use the residual plot to be able to determine if an outlier exists in your bivariate data.